This is the Wan 2.2 Animate, Alibaba's purpose-built motion transfer and character replacement model. You give it a reference portrait and a driving video, and it animates your character to match that motion, body, facial expressions, movement, timing, everything, while preserving the original subject's appearance. This workflow is cleanly organized into 8 groups, and I'm going to walk through each one in order, left to right, top to bottom, exactly how data flows through the graph. Let's go. Starting with the resolution group, we set the width to 480 pixels and the height to 832 pixels. It's portrait orientation, 9:16 aspect ratio. This is Wan 2.2 Animate's native training resolution. From here, the width and the height resolution constants propagate through the entire workflow and are set as a global resolution. Every downstream node that needs dimensions all pull from the same 2 constants. This is smart workflow design. If you ever need to change the resolution, you change it in one place. The driving video group is where your motion source comes in. The video loads with a force rate set to 25 FPS. This normalizes whatever your source video's original frame rate was. Your video might be 30 FPS, 24 FPS, but it will be resampled to 25 FPS before anything downstream even sees it. We disable force size. Instead, we set the custom width and the custom height through our global resolution constants. So the video gets loaded and decoded at exactly 480 by 832 pixels. The reference image group, this is where you place your subject. The resize settings are important. The resize method that we use is lanczos. It provides high quality downscaling. The resize mode is crop, not stretch, not letterbox. So your subject's proportions are preserved. It just cuts what does not fit. The resized image gets stored via the set reference image, and there's a preview image node in line so you can verify exactly how your portrait was cropped before running the full generation. Check this every time you change your reference image. A badly cropped reference is one of the most common causes of poor results. The pre-processing group is the most complex section in this workflow. There are 3 parallel pipelines running here: pose extraction, face extraction, and segmentation, all happening on your driving video before the diffusion model ever runs. For pose detection, we load 2 models together: YOLOv10M for person detection and bounding box creation around the person, ViTPose Large Wholebody. This model is used for full body keypoint estimation. Both are ONNX models running on your GPU through the ONNX runtime, not PyTorch. ONNX is faster and has lower overhead compared to a PyTorch-based equivalent. The pose and face detection node runs the full detection pipeline across every frame of the driving video in a single pass. It outputs 5 things: pose data, which is the raw structured key point data; face images, which are the cropped facial regions from each frame; bounding boxes, which are the per frame person bounding box; and 2 other outputs: keyframe body points and face bounding boxes, though we are not using them here. The pose data goes into the draw VITPose node, which renders the skeleton overlays, basically the colored stick figure visualization that you can see in the preview node. Always check the body pose estimations. If your driving video has crowded scenes or unusual body positions, the pose detection might fail on certain frames, and you'll see it here. Face images, the cropped face batch, gets stored in the set face images node with its own preview combine node. The video model uses these as per frame identity and facial expression anchors to maintain facial likeness across the animation. Parallel to face extraction and pose extraction, we run the SAM2 model, segment anything model. In this video, SAM2 propagates segmentation masks using interframe context to maintain a coherent and stable mask across the full video. If it was in image mode, SAM2 will treat each frame independently and you'll get a mask that flickers, so do not use image mode. The SAM2 segmentation node receives the SAM model, the video frames, and the bounding boxes output from the VAE pose detection. The bounding boxes tell SAM model where the person is in each frame, so it does not have to guess. If SAM gives you a poor mask, you have an alternative. You just wire in the keyframe body points output from the pose and face detection node into the coordinates positive input instead of bounding boxes. One of the two usually works better depending on your source video, so you're gonna have to figure that out. It depends on a case-by-case basis. The raw mask goes through the grow mask with blur node. We expand it by 15 pixels. This expansion adds a safety margin so the mask does not clip the edges of your subject. Think hair and clothing edges. They specifically benefit from this. The models group handles all model loading. The Wan video torch compile setting node sets up the torch compilation configuration. When enabled, this will provide you a 20 to 40% speed up after the first warm-up run. Wan video block swap block works by keeping the majority of the transformers block loaded in the CPU's RAM, and it streams them into the GPU only for their forward pass. 25 blocks is a significant offload. It lets the 14 billion parameter model run on GPUs that otherwise won't be able to run it. The trade-off is generation time, since each block transfer will add latency. The Wan video model loader node loads the main model, Wan 2.2 Animate, 14 billion parameter, BF16 precision. We set the attention mode to Sage Attention. Make sure this is installed in your computer if you don't have it. This will significantly help speed up the generation process. Coming on to the LoRa loader node, we load LightX2V LoRa. This is a step distillation LoRa, meaning what normally requires 20 to 30 steps can now be done in 4 steps. And the output at 4 steps with this LoRa is comparable to 20 steps without it. Then we load the VAE. We use Wan 2.1 VAE. Both Wan 2.1 and 2.2 use the same VAE because they have the same architecture. It's used in 2 places for encoding the embeddings and decoding the final latent samples. The ClipVision model that we load here converts our reference image to image embeddings. The embeddings generator group is where all the conditioning signals get assembled into a single package that the sampler consumes downstream. The Wan video ClipVision encode encodes the reference image that we provide through the ClipVision H model. Coming on to the core node is Wan video Animate embeds. Let's go through the inputs. Clip embeds, the ClipVision embeddings from the previous node. Pose images, this is the VAE pose skeleton key pose estimations that we generated in the pre-processing group. Face images, this is the cropped face patches. Background images, this is where we have the background frames with the person masked out. The mask, it's the SAM2 segmentation mask, telling the model exactly where the person resides. You can disconnect the background images and the mask to perform motion transfer onto the reference image. When they are kept connected, we are doing character replacement, meaning our character from reference image is placed in the driving video. When we disconnect this, our reference image will be animated and it'll do the motion that is derived from the driving video. Coming on to the sampling and VAE Decode group, we set the steps to 4. This is only possible because of the LightX2V LoRa. Without this LoRa, you would need at least 20 to 30 steps minimum. CFG scale is set to 1. Running a CFG higher than 1 with a distilled LoRa will produce oversaturated and artifact heavy output. Do not do it. The output latent goes straight into Wan video decode. Here we set the enable VAE tiling to false, meaning tiling is disabled. This essentially means that the full latent volume is decoded at once. If you run into out-of-memory errors during decoding, enable this. And this is the final output group, where you can preview and export the image if it's up to your likeness. And that's pretty much it. If you like this video, subscribe. If you have any questions, put it down in the comments. I'll see you later.